Welcome to this session. I'm still Teacher Peter, taking you through science. And still in science, we are looking at light energy. We've discussed already in our previous lessons several things in science. I remember in our previous lesson, we looked at the luminous objects, and we also gave examples of the luminous objects. We looked at the non-luminous objects and also gave examples of the non-luminous objects, if you can remember. We looked at the incandescent objects, and we also gave examples of the incandescent objects. We also looked at how light travels, and we said that light travels in a straight line. We also looked at an experiment to show that really light travels in a straight line. For today, I want us to begin with the correction of our previous work. I remember giving you an activity, and these are the corrections of that activity. Our number one was saying, what are luminous objects? And our answer is, luminous objects are objects that emit light on their own. Number two was saying, identify any two examples of luminous objects. And the answer is the sun and the stars. Then number three was saying, in the space below, draw two artificial sources of light of your own choice. So for me, I chose these ones here. I drew a candle and I also drew an electric lamp. Then number four was saying, why is the moon not regarded as a natural source of light? It reflects light from the sun. That is the reason as why it is not regarded as a natural source of light. Then number five says, what are incandescent objects? And the answer is, these are objects that emit light when they are hot. Then number six was saying, write down the use of light to plants. And the answer is, light enables plants to make their own food called starch. Then number seven is saying, how is sunlight useful to our bodies? Then the answer is, the sun helps our skins to make vitamin D. Number eight says, write down two properties of light. The first one is light travels in a straight line, and secondly, light forms shadows when obstructed. Then number nine says, list down two examples of non-luminous objects. And the examples we have are the moon and the planet. Number 10 says, identify any two objects that emit light when they are hot. Then our answers we have is the sun and hot charcoal. Number 11 says, describe the way you can see an object. Then the answer is, we can see an object when it reflects light to our eyes. Then number 12 lastly says, Mr. Blakey was going to office in the morning and he saw two bulls fighting. Which form of energy enabled him to see the bulls fighting? And the answer is light energy. That was our activity that we did. Please, Blakey and Molly, I expect you people to do this work in your books. You will hand in that work when you come back for the face-to-face sessions. But that very activity, I've designed it and I've put it on the live worksheets. Please, I want you to go to the live worksheets and do that very work. I want us to engage. I want us to keep in engagement. We've already lost enough time. Please try to see that you always do the work on the live worksheets, because I don't just end at posting this work, uploading this work on YouTube, but even on the live worksheets, I always put there the activities. So please, sorry for that, endeavor to see that you do the work on the live worksheets. Now let's go on. For today, I want us to start like this. I want us to look at the factors in our daily life to prove that light travels in a straight line. Yes, light, we've already said that one of its properties is that it travels in a straight line. But in our daily life, what can show us really that light travels in a straight line? Let's read the first statement. We cannot see around corners because light travels in a straight line. That is correct. We can't see around corners. I know you have ever played the game of hide and seek, and you could look for somebody and you fail even to get that person. Why? Because the person is hiding maybe in a certain corner, and you cannot see that person. The reason is light travels in a straight line. We said that we can only see an object when it reflects the light to our eyes. Now, if somebody is hiding in a corner, how will light be reflected into your eyes? Definitely, you will not be able to see that person because light cannot fall onto that person and it's reflected into your eyes. So, we cannot see around corners because the light travels in a straight line. Let's read the next one. It says, shadows occur because the light travels in a straight line. Yes. Because light travels in a straight line, if you try to obstruct light, it will instead form a shadow. Light cannot bypass an obstruction. It will strike onto that material and it will instead form a shadow. That is why shadows are formed altogether. Yes, shadows occur because light travels in a straight line. If light could bend around corners, there would be no shadows. That is also correct. Yes, if light could bend, then where would the shadow come from? The light would just bypass the obstruction and continues its own way. But because it travels in a straight line, it cannot bend. That's why you always see a shadow formed. Then next, the light from the setting sun is often seen travel in a straight line, especially when the sky is cloudy. Try this in the evening when the sun is setting at around 6 o'clock. Don't try it at midday. It will spoil your eyes. But in the evening at around 6 when the sun is setting, look at the sky. You always see light rays penetrating out of the clouds altogether. That will also show you that really light travels in a straight line. Let's go on and look at rays and beams of light. What is a ray? A ray is a path taken by light in a particular direction. A ray is a path taken by light in a particular direction. A ray is represented by a straight line with an arrow on it to show the direction of what? The direction of light. Now this is a ray. This ray is a straight line with an arrow pointing this direction, meaning that light is traveling going to this direction. Are we together? So a ray is a straight line that has even an arrow here. Are we together? It is always drawn out together with an arrow there. What about a beam? A beam is a group of light rays. A beam is a group of light rays. Or we can say that a beam is a stream of light energy. So when you combine 1, 2, 3 light rays, what you form is what we call a beam. A beam is formed by several light rays. All together, a beam is formed by several light rays. So when you combine several light rays, 1, 2, 3, 4 light rays, yes, they form what we call a beam, or they form what we call a stream of light. Let's look at the types of beams. We have got parallel beams. Yes, I know most of you have come into contact with this word parallel. That is in mathematics. You have always been defining parallel lines, and you have always said parallel lines are lines which do not meet. Yes, but here we are now in science, and we are still using the same vocabulary. But this time we are studying about beams, and we are calling this type of beam parallel beam. What is a parallel beam? This is a beam of light which has light rays that do not meet at all in their path. This is a beam of light which has light rays that do not meet at all in their path, like this one here. This is a beam of light with light rays which do not meet at all in their path. Now, like you can see this light ray and this light ray, they don't meet. They are parallel to each other. they are equidistant to each other. They don't meet. That's why we call this type of beam the parallel beam of light. Are we together? Let's look at the second one. We have the diverging beam. Diverging. Please, these spellings are not so familiar to you. I want you to always pause the screen. Don't just watch this like a movie. Pause the screen and spell these words and let them stick in your brains. This is when the rays spread out from a common source. Yes, this is when the rays spread out from a common source. Just like you can see this diagram here, I have a diverging beam here. I have a common source here where I'm pointing right now. This is the source of light. Maybe it might be a torch, it might be a bulb, it might be a candle. Yes. Now, from the source, which is here, the light rays start spreading out to different directions. Observe these arrows. They are going to the other side. Altogether, they are spreading out. Yes, meaning that this type of beam is the one we are calling the diverging. The diverging. It is spreading out light rays. Altogether, the light rays are moving from the source, spreading out. Altogether. Therefore, this type of beam is the one we are referring to as the diverging beam of light. We can always see these diverging beams of light in car headlights, on bicycle headlamps, and in torches. I think you can easily come across a torch. Please carry out this experiment and get a torch and try to switch it on. You will see a diverging beam coming out. You will see a group of light rays coming out of the torch altogether, and that type of beam is the one we are referring to as a diverging beam. Now let's also look at the converging beam. In fact, the opposite of diverging is converging. Altogether, the opposite of diverging is converging. So this is easier for us to understand. Now, this is when the rays meet at a common point. This is when the rays meet at a common point. You can see that the rays are coming from different directions, but they are coming to meet here. Observe these arrows here properly. They are different from these ones here in the diverging beam. These ones are coming to meet. These ones are running away from one another. These ones are coming together. These ones are running away from one another. Now, these ones which are coming to combine here at the common point, these ones are called the converging beam of light. This is what we call a converging beam of light. So if you are told that please draw a converging beam of light, draw something that looks like this. Is that okay? Okay, let's go to the next one. Let's look at examples to prove that light travels faster than sound. You think you are the only one who can run? Yes. Oh, you are the only one who can move. Even sound can move. Even light can do what? Move. Yes, light can move. Even sound can do what? Can move. Now, which one moves faster than the other? We are going to look at these examples in our daily life. That really show us that in fact it is light which moves faster than sound. Let's look at our first example. We hear the sound of thunder after we have seen lightning flash. Please, whenever it is threatening to rain, as a scientist, be observant and look at this and try to observe this when it is almost about to rain. When it is threatening to rain, what always happens? You will always hear sound in the sky. That sound that you hear in the sky is called thunder. That sound which sounds like a bomb, that sound is thunder. And the light, the flashlight that you always see in the sky, we call it lightning. It is called lightning. Now, we are saying in this statement that we hear the sound of thunder after we have seen lightning flash. After seeing lightning flashing, then what do you expect next? That is thunder. Are we together? For me, when I was still young, whenever it was threatening to rain, I would be very keen whenever I would see the flashlight, the lightning in the sky, I would take off and enter under the bed, cover myself with a pillow there, so that I run away from the what? From this thunderstorm, because it is scary altogether. So why would I do that? It is because lightning would warn me that there is something coming. The lightning would warn that there is a certain funny sound coming. You run and hide. So I would run, and by the time the thunder would come, it would meet when I'm already under the what? The bed. What does that prove to us? It proves that really light travels faster than sound, because all of this happens at the same time. For thunder and lightning to occur, what always happens is a positively charged cloud and a negatively charged cloud. When they come and get into contact, a reaction takes place, hence producing sound and light. Now you will always you will always see the light before you hear the sound, and yet the reaction took place at the same time. Yes, these clouds know one another at the same time. But in observation, we always see that light is seen before we hear the sound. It is simple. It is because when that reaction takes place, light travels very fast and we see it. Then sound comes later on. Because sound is slow, it has a slower speed than light. That is why we always see lightning before hearing thunder. Let's go to the next one. At a racetrack, the flash of a starter gun is seen before the bang is heard. At a racetrack where people are racing, maybe cars going to race, maybe politicians, crew, they are going to have a race. They always use what we call a starter gun to enable them to start. They tell them on your marks, get set, ha! Then they take off. Now, what always happens when they shoot the starter gun? We shall always see the flashlight. We shall always see the flashlight before hearing the bang. Before hearing the bang. This bang, you can also call it the sound. Before hearing the sound of the starter gun. That can also prove to us that real light travels faster than sound. Let's go to the next. Let's look at C. The sound of the axe is heard after we have seen the axe striking when cutting a tree. The sound of the axe is heard after we have seen the axe striking when cutting a tree. Now, that is seeing the axe striking is like a seeing light. It is like a seeing what? Light. But you will always see the axe striking. Then after seeing the axe passing, then you will hear the sound. That is a result of banging the tree. That also proves to us that really light travels faster than sound. Okay, let's go on and look at how light travels through materials. How does light travel through materials? Through materials. How does light travel through materials? We have got different materials in our environment. Some of the materials we have is transparent. We shall be looking at what transparent objects mean. Some of the materials we have are translucent. We shall also look in details at what translucent objects are. Then we also have the opaque objects. Let's start. Let's look at the transparent objects. What are transparent objects? These are objects or materials which allow all the light to pass through them. Correct. These are objects or materials which allow all the light to pass through them. We are also saying that we are able to see through transparent materials. We are able to see through transparent materials. Let's look at the examples of transparent materials. We have clear glass. Yes, clear glass is a transparent glass. These breakable glasses you always use at home to take water. Yes, when you pour water in that glass, you can even look at it and you will be able to know that really in this glass there are some particles in it, so you will not drink the water. Why? Because it is a clear glass, it is a transparent glass. Light can pass through it for you to be able to see the particles which are in water. Then we have also clear water. Clear water is also a transparent material or object. Are we together? So, take an example. If you go to a swimming pool and you look through clean water in a swimming pool, you can see at the bottom of the swimming pool, just because clear water is also a transparent object. Then we have air. Air is also transparent. That is why you can see your neighbor where you are seated. You can even see the things around you. You can even see everything that is in the house. That is just because air is transparent. It can allow light to pass through it. Are we together? Yes, it can allow all the light to pass through it. Then we have also the vacuum. Yes, a vacuum light can also pass through a vacuum. And let's also look at the spectacles or the garubindi. The Bagandas call spectacles garubindi. Some people call them goggles. Yes, let's look at the goggles, but for this we are calling them the spectacles. Yes, the spectacles are also transparent objects. They allow light to pass through them easily. That's why people put them on their eyes and move and go wherever they want to go. They can even drive cars and go. Why? Because spectacles are transparent objects. Let's go on and look at another one that we call the translucent objects. Yes, we also have objects that we call the translucent. I told you pause your screen and spell these words properly. Translucent objects. What are translucent objects? These are materials which allow some light to pass through, but we do not see them. We do not see through them. These are materials which allow some light to pass through, but we cannot see through them. Yes, there are some materials which can allow some light, not all, but some, little light. You can even call it little light. These are materials which can allow little light to pass through them, but we cannot see through them. What are they? Let's look at their examples. We have the skylights. Yes, skylights are examples of translucent objects. We have frosted glass or church window glasses. Yes, have you ever seen church window glasses? Especially these churches of the Catholics. Some of you even have these glasses at home, on the toilets, on the bathrooms, the frosted glasses. These frosted glasses, when you try to look through them, you cannot look through them, you cannot see through them, but some little light can pass through them. Then we have the waxed oiled paper. Waxed or oiled paper. Yes, if you get a piece of paper and you oil it, you get cooking oil and you smear on that paper, it becomes oiled. Are we together? Or if you get wax and then you smear on that paper, it becomes waxed. Now that oiled paper is also an example of a translucent object. That oiled paper will be able to allow some little light to pass through it, but you yourself will not be able to use your eyes to see through it. Let's continue. Then we have we are saying that still with the translucent objects, we have said that these are materials which allow some light to pass through, but we cannot see through them. That one we have already. We have also looked at the skylights, yes. Then down here we have the tissue paper. Tissue paper. The tissue paper, that is the toilet paper. Yes, it is also a translucent material. Then we have got the polythene paper, we have got the light cloth, we have got light bulbs. Then lastly we are saying that little light passes through translucent objects because of diffusion. So why does little light pass through translucent objects? Little light passes through translucent objects because of diffusion. We shall be looking at that in our next lessons to come. So ladies and gentlemen, that is Blake and Molly, we have an activity now here, and in this activity I want us to look at these questions, and please write them down there on your live worksheets. Please try them out and you'll become the best in science. Question number 1 says, what is a ray? Question number 2 says, write down any 2 properties of light you know. Question number 3 says, write down one example of a transparent object. Question number 4 says, what is a beam of light? Question number 5 says, write down any one type of beam you know. Question number 6 says, what happens when light is obstructed? Question number 7 says, state an example to prove that light travels faster than sound. Then number 8 says, define the following terms: opaque objects, translucent objects, then the transparent objects. Number 9 says, materials that allow little light to pass through them are called, you give the answer. Number 10 says, write down one example of an artificial source of light. 11 says, write down one example of an artificial source of light. I think it is a repetition, don't mind. And that is, I think, all we have for today. I only urge you to do your work in time, send your live worksheets in time, and I wish you the best. Take care. Bye-bye.